Now, of course, I mean, the thing with the algorithms in Photosynth is that you can only see what was photographed, and you're never going to get a 3D reconstruction of anything that wasn't in the photos. So, if you want to get an environment thoroughly, then you'll need quite a few. That's especially true for indoor environments. It's one of the things that we don't really notice about digital cameras these days is how narrow the field of view is. So if you try to capture any kind of inside environment, you'll find that even just this auditorium will require probably about 100 shots just to get everything. Okay, the question is, are we using Silverlight for the GUI of the client-side application? And I'm sorry to say that the answer is no. Now we do have the basic Seadragon capabilities going into this next refresh of Silverlight, which is very exciting. But so you can do the scaling and the zooming and so on now in Silverlight. But what Silverlight and for that matter Flash also both lack at the moment is 3D. And in particular, they both lack the ability to projectively texture images. So until that's possible to do, it'll be very hard to make a Silverlight version of the real 3D viewer. What the 3D viewer is right now is an ActiveX control, so it's all native code, binary code. Well, it's an ActiveX control, just like the Flash player itself is, or like Silverlight is. So you go to the web page and you click yes, and then it works in the web page. But it is a binary of a couple of megabytes that ends up getting installed. Yeah, and you can uninstall it in the usual ways. It works in both Internet Explorer and Firefox as well. If I had my way, we would also have by now a Mac port, by the way, and for that matter a Linux port as well. But our development resources have been quite limited, and we're really much more concerned right now about just getting it out there in some form or other. So we supported both IE and Firefox because the underlying hardware is the same, and they're both using Direct3D. The problem with things like making the Mac port is that requires an OpenGL implementation as well. It's a very different architecture, a lot more work. Yes.
What exactly is functionality uses? So what are you doing to enable people to collaborate?
Okay. Yeah.
What are the applications to usability?
Okay, so two very good questions. One of them is, where's the Web 2.0 in all of this? What are you doing to allow people to collaborate when you release this? And the second is, I think your second question is, what can you do with this, right? What's it good for? I need to go a little bit carefully here because I don't actually want to spill beans about what features we're going to be putting in the release. We'd like to surprise people. But let's just say that it's obviously very appealing and interesting to be able to take a synth on your own and capture an environment that way. There's a lot of value in that alone. And there's also obviously yet more value when multiple users are able to work together. And I think I'm going to have to leave the question at that. We're certainly thinking about all kinds of interesting ideas along those lines, and we have a pretty good idea of what we're going to be shipping with, and it should be quite Web 2.0-ish. Now, with respect to what does this let you do, how does it change the desktop, or what does it enable? Again, I'm afraid I'm not going to be able to give a completely satisfactory answer for a variety of reasons. But let's just say that I see this as being much more important than just, for example, QuickTime VR, which let you, or a panorama stitcher or something. This is really a technology that lets images build up organically into real worlds. And in that sense, we've all, my generation, all of you, you've grown up with the idea of cyberspace. This was in all the cyberpunk novels of the 1980s and 90s, and slowly the term cyberspace has just come to mean the web. But that's not really cyberspace, I think. The web is text and images. Real real cyberspace is a mirror of the real world and maybe an augmented world. Of course, authoring those things using conventional 3D authoring tools or doing it the way Second Life does it is interesting, but if suddenly you're able to author those environments with the kind of scale that you can get by just synthesizing ordinary photos, I think that just blows the lid off of the whole thing. It becomes so much bigger when the barrier to creation of the world lowers in that way. Yes?
Which are the basic languages required to program the software?
Well, okay, the question is, which are the basic languages required to program the software? So we programmed the client side entirely in C++, and the synther as well. So C++ is the most important one. We've also used a variety of other things like Python for prototyping various things.
Excuse me? Can we scan the old photographs and then put and create an atmosphere what it was years back, the old photographs and scan them and then
Yes, absolutely. But the question is, can you does it work for old photographs as well? And the answer is absolutely yes. In fact, one of Noah's first demonstrations in phototourism included it was of a very beautiful small mountain called Half Dome Rock in Yosemite Park in the United States, and he had both a number of contemporary photos of Half Dome as well as a very famous photo from I think the 40s by Ansel Adams. And by adding that one, you could figure out exactly where Ansel Adams was standing when he took this photo, and it forms part of the synth. So yeah, historical is very interesting. I'm sorry, I cut you off.
Does this have applications to CAD/CAM software?
Okay, the question is, does this have applications to CAD/CAM software? Of course, often CAD/CAM is used to design something before it exists in the real world. And if it doesn't exist in the real world, then it won't help you. But to the extent that CAD/CAM can be used to reverse engineer things that already exist in the real world, or things that have been mocked up or modeled physically, yeah, I think it can be very valuable in those kinds of scenarios.
Assembling everything together. I see this. So you can have all the machines together. I can assemble it better. So can you put this together along with the CAD/CAM software so that?
Potentially, this could be put together with CAD/CAM software. We don't have any immediate plans to do it, but I can think of some interesting ways in which that could happen. Well, I can't give you a date or an amount of time, but I see over the next 3 or 4 years a very, very large number of applications that I'm sure will be branching out into. That seems like a very good candidate.
I have a very specific question. You in the demo of the human cathedral, you generated a point cloud and then created a polygonal mesh out of it.
Yes.
So, I just wanted to know what type of algorithm or a method you used there. There is a linear least square method which does that, but it works for a single object. When you have multiple objects, how do you do that? So, can you give me a brief, or you got a paper published somewhere?
Yes. Well, so without spilling the beans too much about the various algorithms, there is a very nice piece of published work that you may want to have a look at if you're interested. It's by Hughes Hoppe, who is a Microsoft research scientist, and it's on Poisson methods for 3D reconstruction. The question, sorry, was a technical one about how the 3D reconstructions are done. Is it a polygonal mesh that's made directly from the point cloud or not? So yeah, and the answer is there are techniques for doing this that are more general than just making a mesh out of those points.
We have said that we can use for 3D vision. By using photos, we can have a 3D reconstruction of whatever the space was. So how useful these algorithms are for modeling someone's face, for example, a 3D model of face or
Sure.
something like that. Because the face has many features, many distinct features which can be used rather than some photograph of one physics of face.
Yes, it's true. The question is about modeling 3D faces from multiple photos. So in principle, it's certainly possible. I think it's important to point out that faces are not the types types of 3D objects that are best dealt with by the particular kinds of feature detectors and algorithms that we're using here. Because, first of all, faces are deformable. And when something is deformable, then the 3D construction fails. So you have to be standing quite still. And also faces, unless they're very straggly looking like yours or mine, tend to not have very many corners or features of the type that the algorithm picks up on. If it's smooth, it doesn't do so well. So in particular for faces, the problem is specialized and interesting enough that there's a whole other class of algorithms that's really well suited to doing face recognition, face detection. There's a company called Polar Rose that has done some very interesting work on reconstructing faces, and because there's such a strong prior on what a face looks like, it's even possible to do it from one image pretty reliably, which Polar Rose has done. So yes, it can be done. Are these algorithms in particular very useful for it? Not as much.